Okay, to summarize our three examples, looking at the shear diagrams and the moment diagrams, we have them laid out here before us. Let's look at some observations that we might be able to make about these different examples. So one observation that we might get is that at an unsupported end, which is a cantilever beam, or a pin-supported end of a beam, we have our moment equals 0, right? If there is no applied moment at that location. So if we go back and look, we see we have cantilever beam for this example, another cantilever beam. We have a pin with no applied moment, and note that our moment is always 0, and that's very important to remember. I always say pins don't have moments, and this proves it at this location also, unless there's an applied moment, and there is no applied moment. Let's look at the next observation. It says a built-in support, so this is our cantilever beam. The absolute of the moment is equal to the reaction force. So the values are the same at each. So if we look at this, if I would calculate the reaction force here for the moment, I would get that same value. Same here. If I calculated it out also. The next one that we have, the observation, is at a pin or roller supported end of a beam with no applied force to it, no applied force. A distributed load may be there. Our shear force is equal to our reaction force. So let's look at that. If we look at this for a pin support, we have at this A, we had a reaction force of 10 kilonewtons, and that is exactly what we have in our shear. That's what the reaction force is. Even though there's a distributed load there, that doesn't matter. Our reaction force is equal to that reaction force. The next observation is at an unsupported end of a beam with no applied point force, a distributed force might be there. The absolute value of our shear is equal to that applied force. Let's look at what that is. So if we look, we see for our cantilever beam, we have this value of negative P. That's what our load is here, negative P for that unsupported end. We see over here, we have no applied force here. It is actually 0 at this location, even though we have a distributed load. And our last observation that we have, it says, at a pin or roller support between ends of the beam, our shear is a change in shear is what we get for that reaction force. So let's look at what that means. This is a good example here of that. If we look at this B, that reaction force that we found there was 30 kilonewtons. So if we look at this distance, that is 30 kilonewtons. So that is what we're seeing as far as our change in our shear force at that location. Okay, a few other observations that we want to make about this is looking at the where this shear crossed the x-axis. We noticed that that was a maximum for us, right? Other observations that we're going to want to make are between the shear and moment diagram. We'll look at that in the next chapter. Also between the distributed load and the shear, and then again the shear to the moment diagram. There are these specific relationships which we can essentially draw our shear and moment diagrams without having to know the function of x. But we still may want to know the function of x, so we kind of have to do this process also.